Okay, question 2, relative velocity. So you have somebody trying to intercept somebody else. So Alan's running over here for some apparent reason, and then B has to intercept him. Could just call out, but no, he's to run over and grab him. So he's traveling up this way. B has to. So the fact that they have to intercept means he has to meet. So with all these questions, you're looking for a triangle, and the fact that they meet means there will be a triangle. So that's, and the question normally is whether to draw a velocity triangle or a distance triangle. In this case, you're given this nice distance of 80 there, which kind of lends itself maybe to drawing a distance, and that's alpha, or no, 45, and that one is alpha. This guy, Brian, sees Alan's, waits 8 seconds, so Alan has the run on this guy, so he's ahead. Yeah, he's got t plus 8, so he's 8 seconds ahead, and that guy is just t. So so the reason I'm multiplying, so he's 4, yeah, so he's running 4t. So really I'm multiplying, speed is equal to distance over time, so distance is equal to velocity by time. So we're saying he's going to take t seconds to intercept him, and then we have the velocities, so we're going to get the distances by multiplying each velocity by time. So the velocities are different, but also the times are different, because Alan has 8 seconds ahead of this guy, so that's going to be longer, and they meet at this point. Grand, so you have to find t and you have to find alpha. So with any triangle here, with these relative velocity equations, sine rule is going to be useful to you. Over 2.5 t plus 8. So I'd say, if in doubt, just write out all aspects of the sine rule. So that's that angle over that. Sine 45 is going to be a nice easy one for you, over 4t. And then the other angle is, they all add up to 180, so it'll be 135 minus alpha, yeah? Over 80 meters. Okay, so you don't know alpha, you don't know t. Okay, so you have enough equations there to be able to work it out using just the sine rule, but an easier one would be to use the cosine rule, because you have this nice clean angle there. So by using the cosine rule on that angle and that opposite side, that'll be much easier. So it'll give you 4t squared, and so it's the length to the side of it, minus 2 that by that, cos of 45. And you know, cos of 45 is a nice easy one, and then that'll give you t. T will pop out of that. You could, I think, use the sine rule there, because you've got that equals that, got that equals that, and got that equals that. So you've actually 3 equations and 3 unknowns. Is it 3 unknowns? No, it's just 2 unknowns, alpha and t. So you could do it that way, but cosine rule probably easier, just in one line do it. So you get t out of that. And then once you have t, definitely you can use the cosine rule, because everything up here is nice and easy then, because you have sine alpha over something that you know, it's now going to be a constant, because t is known, is equal to that, which is just 1 over root 2. And then you're going to have a constant underneath there as well, is equal to 135 minus alpha over 80. So by banging it into one of these, you can easily get sine alpha. Probably this one, because you don't have to worry about the 135. So that'll give you alpha. So that's fairly straightforward. Okay, the aircraft, P is traveling at this, Q is traveling at this. Okay, P is traveling north. So just very important to get your vectors right. Just make sure, because they try and twist you with these north 30 degrees east kind of ones, so make sure you get those okay. So VP is 450, Q in the direction east. Okay, so So Q is traveling if in a direction east and north. So VQ there, that's 45, and VQ is 400 root 2, okay? Because that's 45, the root 2 will come out cancelling nice and easy. Then, so R appears to be by the pilot of P. So the velocity of R relative to P. So that's important that you interpret it that. R appears to the pilot to be flying in the direction of east 10 degrees south. So it's east 10 degrees south. And then R appears to the pilot east 15 degrees south. Okay. That's 10, that's 15. Okay, so you're given two values of RP. So you're not given the magnitude of this. So let's, not one of them equals X. And it's going to be, okay, so the first one relative, this one is going to be relative to Q. So relative to P, it's an angle of 10. So it's going to be cos of 10I plus X, well, negative X minus X sine 10J. This one, let's call it Y being the magnitude. So cos 15I minus Y sine 15J. All right. Then separately, okay, let's get the vectors for VP. Well, that'll be simple 450J, and VQ will be equal to the magnitude by cos of 45. Nice cancellation there because cos 45 is 1 over root 2. So that will be 2 by 400, is it? Yeah. No, it'll cancel. So it'll be equal to 400 plus 400I plus 400J. Is that right? Yeah, because it'll be 400 cos 45 is 1 over 2. Yeah. Okay. So now you have VP, you have VQ, and then you have these guys, and you can just then write your equation VRP is equal to VR minus VP. You have VP fully. You've now, so then you get an equation for VR. It's equal to VRP plus VP. So, and then do it for the same one. It's equal to VRQ plus VQ. You know this, you have these popped in with the variables X and Q, X and Y. So you have two equations and two unknowns in X and Y. Solve for both X and Y, pop them in there, and you get R VRP. You're asked, it's important to know what you're asked first. So you're asked for the magnitude and direction of R. So you just need X. Well, you just need to pop one of them in here. So for VR, and so magnitude and direction. So you get your, make sure you get your, that's your magnitude, and then that's the direction, and give it in the format that they've given you. So that would be, say if it is that, it would be east alpha degrees north. Okay, so that's reasonably okay, I would say, that relative velocity question overall. That one, once you know what you're doing and you just apply the cosine rule and sine rule, is very straightforward, and it can be over pretty quickly. And this one is fairly straightforward as well, I would think, as relative